Okay. Okay, so here we go. Let's take a look at some things. Jesus, why don't you get out something to write with, get out your test, and make some corrections. That would be my strong recommendation. Okay. Oh, yes. Go ahead and grab your book, and you can use that front page. Up top. Yep. Okay. Okay. So here, let's just kind of scroll through this here real quick. There were some things I was pleased with, and some things I was like, I wonder why that didn't go a little better. And then there was, there's evidence that we just have a couple people that just fell a little bit behind and just let it happen. So
can you, on the first one, can you not factor out a 3 on the top left?
Yes, I should have. So yes, I could factor out a 3 and then rewrite it as multiplication and then cancel it. I could, and I did not do that. What I do is when I make my key, I time myself, and then I try and do it fairly quickly, and then I multiply whatever time it takes me by 6, and that's usually pretty darn accurate for kids. It's nuts how accurate it is. When I first heard that, I was like, nah. So I was trying to go too fast. But yes, you are exactly right. Okay, so here we go. Addressing issues that we had. X to the third, you're differentiating with respect to x, so there's no dy dx. If there was anything, it would be dx dx, which is 1. So 3x squared, 3y squared, but I differentiate with respect to y, so there's my dy dx equals, now it's product rule. I had a lot of times where people did not use product rule when they should have used product rule. So that is something we need to get better at, no doubt about it. Here we have a product of two different things, which is x and y. And then we've got to go ahead and use product rule. So the derivative of y is dy dx. So I got 18x dy dx plus 18y. Why is there nothing else? Because the derivative of x is just 1. And then the rest I think we can handle. It's just if we made mistakes, it was largely just on that first step. Okay? Okay. I'm going to scroll out just a little bit here. Next one. 2y dy dx minus 2. Again, I differentiate something that had a y in it. That changes at a different rate with x. So I need to do y dx minus 2. And then this 1 disappears. Derivative of 1 is nothing. The slope of 1 is nothing. So then I have negative 2 dy dx, and then the rest goes pretty well. And again, I should have simplified that to 1 over y plus 1. Yeah, yep. Okay. Yeah, 1 over y plus 1 would have been better. And then you plug in your y value, and then one thing I thought was intriguing is that the slope of this thing doesn't depend on x at all. It's just my y. Because there's no place to plug in your x value. So I was like, that's kind of interesting. So my x doesn't matter. My y is enough to define my slope. Just out of curiosity, if I was going to graph this, any idea what it would look like? No, it would be a parabola. It would be a sideways parabola because it's y squared instead of x squared. Okay? So then, that's what it might look like. Okay. 2, the derivative of natural log is 1 over. Okay, a couple people didn't have that in their brains. The derivative of natural log of x is 1 over x. So the natural log of x a third is 1 over x to the third times dy dx. Okay? E to the x is simply e to the x, but natural log is not just natural log when you derivate it or whatever, however you say that. I'm not very good at that sort of stuff. Okay? And then you can simplify it down to 3 over x. Thank you, Hunter. You done?
Yeah, thank you.
Yep, good job getting here early. And then this one, so dy dx, or just y prime, or whatever you want to say, 1 over secant. The derivative of secant is secant tangent, and the derivative of my nested function is 2x. Okay, you don't have to worry about simplifying that. Okay. This one. Yeah, it's product rule. Why? Because we've got two different, my input is theta, and I don't care whether we're doing this with respect to x or with respect to whatever, but I just, we're just doing dr d theta. There's an expression with theta and another expression with theta, so you've got to use product rule. Okay? So, derivative of the first part, 2 theta, is just 2, and the second part stays by itself, or stays in its original form. Plus 2 theta times the derivative of this part, and we had a little bit of struggle with chain rule, so I'll talk about that a little bit. This is cosine of 1/2, so 1/2 cosine of negative 1/2, and then the derivative of the nested function, which is negative sine theta. Okay. Okay. This one here, we are differentiating a inverse sine. Later on that problem where I had the secant of inverse sine, there we weren't differentiating, but this one we are going to use the formula 1 over the square root of 1 minus whatever, and this whatever in this case is x squared times the derivative of 2x. Okay, so that is a chain rule problem, and then you could simplify that quite nicely. I tried to keep the simplification either off the table or just fairly straightforward. Inverse secant on 3. Okay. The derivative here, inverse secant, is this 1 over. Yes, there's an absolute value. I never really talked about that much at all, but 5x to the 4th is always going to be positive, so I just dropped it. And then times the derivative of my nested function, always a chain rule issue. And then we can simplify it a little bit. Now B I'm going to do on a different sheet of paper, because I wish I would have had just a little bit more room to do that. Okay. Definitely a product rule situation. So I'm going to rewrite it so it's a little bit more user-friendly. Okay. Set it up so your eyes can see the layers. Okay. So y equals the derivative of this, 1/2 x, then negative 1/2. This stays the same. Plus, leave the first one alone. Now we just got to go from the outside in. Something to the second power is 2 times that something. I had to put one challenging, more challenging derivative on there. Yes, did I make a mistake?
Shouldn't that be x to the 1/2?
Yes, I'm sorry. Thank you. Okay. So now I've got this inner layer. Tangent is secant squared. So secant squared of 1 plus x, 20 squared. Now I've got this thing here that I have to take the derivative of, times 2 times 1 plus x. And then if you had wanted to note it, the derivative of the next inside function is just 1. And I was happy with just stopping right there, because that was ugly enough. Okay, 4. Let's go back to here. I had mine flipped, but okay, here's the review of this one. Okay. That's an angle. The blue thing, that's an angle. We have to draw a situation that represents that angle. Okay? Well, the angle that we're talking about here must be some theta to give me an opposite of x and a hypotenuse of 5. Okay? So now if I want to find the secant of that, well, then I need to go ahead and find my third side of the triangle, which you can even go like a squared plus x squared equals 25, and then solve for a, 25 minus x squared. Okay, so I got my other side. And now we'll do secant, which secant, again, I have this flip-flopped. Secant is cosine flipped. So cosine would be adjacent over hypotenuse, so it should be hypotenuse over adjacent. Okay. So these problems, honestly, I think far too often students just turn into, okay, I do this step, and I don't really understand what's going on. Here they want the secant of this angle. So in order to do this, we have to draw a situation that has an angle that satisfies that situation. So we've presented this angle here that does have sine to be x over 5, and then I can go ahead and go from there. Okay. 5 was probably my most disappointing problem. Because too many just didn't express anything in terms of any variables at all. So my goal was to do one problem that was different from any problem you've done before to see you handle a new novel situation. Okay? And I searched hard to find one that the math wasn't too hard in it, but just you had to kind of get your brain organized. 2 cars start moving from the same point. Okay? One travels south. Okay, first thing you'll notice is I've got to do this never eat shredded wheat all the time. I have to write that somewhere. Okay? But that's just me. And this often reminds me of, I think somebody who lives in Madison and grows up in Madison, to learn their directions would be really tough. Because what's to the east? West Point. What's to the south? North Bend. I don't know. I don't know. So, anyway. Okay. So 2 cars start from, one travels south. So, okay. I said, okay, look into my south. Here's my south. And they're going to 60 miles per hour. So I got a ds dt is 60 miles per hour. Okay. The other travels west at 25 miles per hour. Okay. At what rate is the distance between the 2 cars? Okay. So I want to find d dt. So now what I've got to do is I've got to relate d, w, and s. Which the math on that's really, really easy. Okay. I'm not denying that some of you guys did some unconventional stuff and found out it was 65, but the process here is as follows. D squared is W squared plus S squared. Pythagorean theorem. Differentiate. 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 And then I'm going to plug in some stuff. Notice what I did here. It says 2 hours later. So after 2 hours, you can find out where they're going to be at. They're going to be 120 miles south, because they did that for 2 hours. They're going to be 50 miles west, because they did that for 2 hours. And then my D is 130. I just pulled out my calculator and did Pythagorean theorem. Okay? Okay. So then I just plugged stuff in and did the math, and you get 65. Okay? So again, I admit you hadn't seen one exactly like that before, but I think that's a good check to see how well you really understand new situations like that. Okay. Because sometimes even ones you had seen before give you difficulty. So like this one here. The first thing you have to do is to write it all in terms of one variable. And what I would recommend strongly is relate it. I've been spending too much time listening to Cat. Relate those two, H and V. Okay, so how did I do that? I said, well, there was an R that I didn't like, so my R is half of my height. So then I plugged in, and right here, some people got to here, but then didn't differentiate or didn't simplify. Okay, because right now, if you differentiate this now, you've really got a product rule. So you've got to combine this into one simpler equation, and then differentiate. Okay, that's a big part that that I think as we go, we'll try and work a little bit more on that. But writing things in terms of just one variable, very important skill. Okay, 7. I did not grade any further than that point right there. Why? Because you guys in the past have used your unit circle sheet that has, you know, the triangles or the labels around the outside or whatever. So once you got it to there, I just quit. How were you supposed to do it? Okay. Well, I think, Haley, that was you that pointed that out, right? Okay, because she asked for a unit circle. I'm like, what? I'm like, oh, okay. So here's the deal. How would I do this? If I look at pi over 4, this is a special triangle. That's a 45 degrees. All your 45-degree triangles have this ratio, 1, 1, square root of 2. Okay, all of them. Period. That's it. Okay? So now if I'm looking at cosine of theta, well, first of all, let's before I get to that, let me just set it up. Okay? So they said dx dt was 2 feet per second, so I'm looking for that. Find d theta dt when theta is pi over 4, looking for that. And then I'm looking for a drawing that represents this situation. So we want theta x related. Okay. Okay, so then I've got, that must be sine. So opposite hypotenuse, sine. Sine of theta is x over 10. Okay. And then you differentiate. Okay, so now how would I do this from here? That's a good question. So I'd have to go cosine of 45, which I did not write this down, but now I'd plug this down. I'd plug this in and be cosine of 45 or pi over 4. if you know this triangle, then you always know cosine of 45. It's 1 over square root of 2, or square root of 2 over 2. And you can write it either way. Okay? So then 1/2, this is changing at 2, so that'd be 1/5, flip, multiply, 2 over 5 square root of 2. Radians per second. I did not check to see if anybody got this answer after that without the unit circle. Did anybody get it? Okay, that's all right. You guys are used to using that unit circle, and you didn't have it, so that's why I stopped right there. Again, I'll ask a lot of you guys, but I'm going to be fair. And then I looked at those 3 problems. I thought, you know what? Let's give them an easy one. And then you got to 8, and you're like, this is a breath of fresh air. Okay? There's pi r squared, dA dt is 2 pi r dr dt. Plug in what you got, and there's my dA dt. Okay. I did not try and put on something impossible for A. I did not. That was not my goal. I was thinking, maybe hoping, that you would remember, and I'm not trying to get on you guys because you just saw this just for an instant, that you've got this Fibonacci sequence. Oh, did I mess up 13, 21? Did I? Okay, and then what you have to do is just look at the proportions of one to the previous. So if you look at 5 over 3, that's 1.6 repeating. 8 over 5 is 1.625. 13 over, it's 1.6. 13 over 8, I'm getting ahead of myself, 1.625. Okay? And then you just kind of keep going until you get that. So, like I said, I wasn't trying to put something that was impossible for you or anything. I was hoping that link would be made. Okay.
Well, I remember it was like something like the golden rule, that video we watched, but I didn't remember like what.
Okay. Where it came from. Yep, I got it. Yeah, you guys didn't seem like you were too enthralled about that information that day, so I don't know what was going on, but you guys were all like...
It was a rough day.
And I was thinking, this is cool, and you guys are all looking at me like, not really. It really isn't, Rexrod. Yes, ma'am.
Can you go back to 2C?
Yes.
I just want to look at it, because
Okay.
I'm not really sure what it was that I got wrong. Yeah, I'm not really sure what I got wrong.
Bring it up. I'll see.
Because I changed it to a plus sign, but I'm not even sure what
Okay.
because I had it a negative before.
Because I changed it to the plus.
No, yeah. Well, I changed it to a plus, but you just circled it, but I'm not really sure why.
Okay. First of all, good job arguing on your behalf. I love
No,
that.
I'm just.
I love it. Okay.
I just want to know what it was.
No, I understand. I understand.
The negative right there. But.
That's a great question. I don't know.
I didn't know if it was because I changed the variable, but I just changed it because it was confusing to me.
Okay, so let me just understand. So this was negative.
Yeah, it was negative, but then I changed it to a positive because that's what I thought was wrong.
Oh, okay. So you changed to a positive just now.
Just now
Okay.
I did.
I don't know. I don't see anything wrong with that. Plus 2 cos.
Rexo, can I go to the bathroom real quick?
Yeah, go ahead. Have a good time. No, I owe you that point back.
Okay.
Good job. Let me Here. Let me change that right now. Good job. I love it when students pay attention to see what they got wrong. Okay. There we go. Okay. Okay, so I guess my advice on this is on everything, just pay attention to your detail on your assignments and your review problems and stuff like that, because if you weren't using product rule and you should be using product rule, that should have been caught probably. Okay, everything here, if you weren't doing natural log is 1 over something, that should have been caught. And the big thing is, don't fall behind. I will be honest with you. I've been, I'll tell you, I should probably stop this recording here for a little bit.